This is a good way.
Yeah, that's my favorite.
How do you deal with people online?
I've only had it streaming. We had that many people watching online. But I did have a customer say that they were planning on having a couple of other people get on and ask questions through the migration.
Okay.
So I've got the app on my phone. I will do my best to keep an eye on people that chatted.
Okay. So they'll use the chat window? Okay.
Not Zoom.
Okay.
I warned you.
How's it going?
Good. You might miss their question.
Your cookies are awesome. Yeah, they can always just reach out.
They can always send a message to like the speed up site if they didn't have to like email.
Okay.
Yeah, there's lots of options for them to talk about that.
What's up, Danny?
Hey, Patrick.
Yeah, is there a restaurant nearby?
Out that way and then that way.
Danny, I wasn't expecting you to make it. Figured it's been pretty chaotic there.
Oh, not for me.
Not for you, just everyone else.
Yeah.
Bill's walking me too.
Oh.
How you been?
I'm pretty good.
Yeah.
I was gonna say, if you didn't show up.
No, I won't be here.
I don't know if anyone else is showing up.
Yeah.
Jeff was at a meeting when I left at last meeting, so,
Okay.
I don't think Tyler's came in today.
Really?
Lance didn't know about it.
Have you been in his office before?
Actually worked here for a while.
Did you?
Yeah, I worked for Humana for about 6 months.
Okay. How long ago?
13 years ago.
Oh wow. Did you go from
Maybe
there?
it wasn't this building. No, I think it was next building.
Getting started slide, so.
But that's one I was thinking about doing. I think this is our crew for the evening.
Yeah.
Okay.
And Bill, we've got, snacks in the back. If anybody hasn't found them yet.
Hey, Bill. When I,
I'm gonna grab something to drink here real quick.
came back around the job. And so, it was 3 months.
All right, well, we'll go ahead and get started. Nick Lawson, I'm sure you all have seen me here before. Kevin Lewis was not able to make it down this week. He decided he was more fun to have strip stroke all week, right before big vacation. So I told him he should just stay home.
Should just put him on one of the screens just to make sure.
There he is.
There he is.
There he is. Oh, look at that.
Well done.
Thank you. So these are the presentations we've had so far. Tonight is going to be VMcloud on AWS. Sorry, that shouldn't have been just Marshall. We have Marshall, Craig, and Stuart all here. I'll let them introduce themselves in just a second. Next month, we're going to do a networking event. So no presentation, nothing formal. We're thinking of having it up at Rec Bar in New Albany. Any feedback on that?
You're all doing right.
People
Some
would come to
feedback?
that? Yeah,
There's a rec bar in J-Town, it's pretty nice.
there is a rec bar in J-Town. I had a request from a group that work out of New Albany to have something on their side of the river.
That's fair, that's fair. We're bringing everybody over here.
Yeah, I thought we could give them one meeting somewhere fun.
That's fair, Nick.
As long as I'm not going to lose all of this audience when we go over there. So I'll get all the details on that squared away and get that posted. And we're still working on topics for the rest of the year. So next slide. I think it's just one. Yeah. For tonight, we had name tags in the back. We did that last time. We have them out again this time. We've also gone around the room before and done quick introductions. Is any interest in going around the room doing quick introductions, or do you just want to jump right into it?
Let's jump right into it.
Okay. All right. Well, then I'll turn it over to these guys if y'all want to do introductions.
Sure. So while they get that loaded, I'm Stuart Urbans. I'm a technical account manager here based in Kentucky. I won't be presenting this presentation, but I have supported VMcloud on AWS. And if anybody here, who here doesn't work for Humana? Okay, so I know you don't. If you have any questions about enterprise support and your entitlements there, if you have any interest in enterprise support, I can speak to that as well after the meeting.
Thanks, Stuart. So my name is Marshall Radwin. I am also a technical account manager with AWS. I've been working with VMcloud on AWS for 5 or 6 years now. Have some historical knowledge of what it was like in the early days. That was kind of a fun time. Been with AWS for about 1.5 years now, and I am based out of Indianapolis. So welcome, appreciate all of you coming out.
Yep, I'm Craig Herring. I'm technically a senior specialist solutions architect, mostly just an SA for VMcloud on AWS. At AWS, I've been with the company for coming up on like 2 years, 4 months, something like that. So super enjoy the company. It's a lot of fun, challenging at times for sure. Previous, I was actually at Dell selling sort of similar solutions, what you'll see with VMcloud on AWS. Did a lot of VxRail, VCF. I've been doing VMware type technology ever since like 2005, 2006 timeframe. Been doing a lot of various consultative and deployment engineering, type roles in my career. Mostly at partners. 2 of the large companies I've been with is Dell and AWS. So yeah, with that, let's kick things off. Yeah.
All right. So before I actually get into the presentation, question for all of you, since this is often an AWS-centric group, how many of you work for a company that has like vSphere on premises right now? Are you sure you do?
I'm pretty sure.
Okay. Just the 2 of you? All right. How many of you have seen VMware Cloud on AWS at another event or know something about it? A little bit?
Okay.
Just a demo a while back. It's been a couple years though.
All right, cool. Just, I like to start off. I believe 2017, if I remember correctly. And what it is vSphere on AWS hardware gives you all of the same components that you're used to on premises, things like vCenter, ESXi, those types of things. But now it's offered as a fully managed service from VMware, right? So you get all the benefits that you get with your on-premises vSphere environment. Now you don't have to worry about the infrastructure because VMware takes care of all of that. Go ahead.
Just a few things here. One of the other key things is we're not changing the code base at all. Right? It's the same code base that you would have on-prem. Same API stack you can see on the top there. vRealize Suite which is now ARIA. Power CLI. If you have other things like Puppet, Chef, Jenkins, they still plug right in. So you still have full access to all the APIs. You see an arrow between the two vCenters there. It's something called hybrid linked mode. Very similar to enhanced link mode on-prem. So we can link the two vCenters together to show you that single pane of glass. However, what's not shared is licensing information. So obviously in this case, it's a fully managed service. All the licensing is taken care of on the back end. So we're not sharing that licensing piece. And you can see the NSX piece. This is what we would call a hyper-converged infrastructure, essentially, where we've got vCenter, vSphere, vSAN, and NSX all running within the same hardware. That NSX piece it rides on top of the AWS global infrastructure and is able to peer into native AWS for access to 200 plus different services.
So for those of you who are working with AWS, we have something called the shared responsibility model, right? AWS is responsible for all of the underlying infrastructure, making sure that that's stable, that it's secure, that it's reliable, and then there is responsibility for you, the customer, to manage things like your data, operating systems, patching of operating systems, and your application configurations, service configurations to support your environment. With VMC on AWS now, VMware takes part of the responsibility for the portions that they are responsible for, and these are the management components like vCenter, like the vSphere hypervisor, vSAN storage, those types of things. So again, this is sort of a little closer look at what the model looks like, and how VMC reduces the undifferentiated heavy lifting for you, right? So again, you can see the areas where VMware takes ownership of the underlying infrastructure, and you, the customer, again, are sharing responsibility for those sections up at the top.
Yep. One other piece here is VMware is your one-stop of support. So you don't engage with AWS and VMware together. VMware does that on the back end for you. So it's essentially kind of the one throat to choke kind of idea.
Did you say one throat to choke?
Sure. Yeah.
Yep.
Is this solution sold through VMware then, or is it sold through AWS or both?
You can do both.
Okay.
Yep. So because this is run on top of AWS hardware, this is available, I think, currently in like 23 of the 31 different regions that are available. And I believe you said there's two new regions that are coming online.
Well, yeah, they just came on Cape Town, down at the south there, and Bahrain in the Middle East.
So those are all outside of the US.
Yep. And as far as any of the attestations or anything, any compliance requirements, VMware's been doing a good job about building out support for all of those. We're gonna skip through some of these.
All right, one of the things I want to do is go through the technical slides fairly quickly. Craig has a couple of demo use cases that we want to try and show you. So what I would ask is, if you have questions on the technical components, let's save those to the very end so that we have enough time to get through as much of the demos as possible. And then we can certainly talk with you afterwards about the specific technical questions that you may have. Right, so as we've described, what is VMC on AWS composed of? You've got VMware's vSphere, you've got vSAN, which is the object storage that is used. You've got VMware NSX, which is the software-defined networking that VMware has developed over the last 10 or 12 years. And then, of course, you've got the AWS global infrastructure, which allows VMC to run in all of those data centers and in all of those AZs and regions.
Yep, a couple key things is this is running on bare metal instances, not nested virtualization. So I get that from a lot of customers. Is this running on, the AWS hypervisor? It's not. There's a technology called EDRS, which is very similar to DRS on-prem, Distributed Resource Scheduler. So this is a technology leveraging the cloud. We're able to, instead of just simply move VMs around, we can add and remove entire nodes. And we can do it in as little as 12 minutes. So we can increase capacity of our SDDC or individual clusters in 12 minutes. Let's see, a couple of the other key things. vSAN, we don't really change it compared to on-prem, if you're familiar with that. It's basically a storage-based policy management system where you can set the policy all the way down at the VMDK level to say, hey, I want this resiliency or this redundancy for my VMDK, or I want this performance level. I want RAID 5, RAID 6, or I want RAID 1, thereby increasing some performance there. NSX that allows us to control north-south traffic and east-west traffic. So it's very similar if you're familiar with AWS's VPC, security constructs and stuff. It's very similar to that. Allows us to control that. And then, like we said, it's running on the AWS global infrastructure, so you're right next to everything else. Like I said, we're right in, bare metal EC2 instances.
Yep. So there are 3 instance types that you may hear about. One of those, the i3, is only available on demand now. The i3EN is the most prevalent type of instance, and these are EC2 instance bare metal types that we're talking about. The i4i is relatively new, and with each different type of instance, what you'll see is that there are differences in CPU, there's differences in the amount of memory, and then the storage is common to them in certain ways as far as EBS goes. And then for the i4i, we have added the AWS Nitro SDDC. I'll let Craig go ahead and talk about that, but there's a number of storage options. We'll talk about that a little bit further as we get into the presentation.
Yeah, and some of the older node types, i3 and i3EN, they're a little bit older. i4i is relatively new. AWS switched to the AWS Nitro SSD because we were noticing performance inconsistencies with the NVMe technology that was included in the older node types. So with the Nitro SSD, we actually write our own firmware to put on those. And from that, we can grab metrics out of those drives to provide our customers a more consistent experience. Some things like, performance, predictive failures, those types of things is what we're looking at. The other key point too, especially if you're in, more secure or really concerned about security or need something that's FedRamped, the two i4i and the i3EN, those actually have in transit encryption at the NIC level, so at the hardware level. That was important for FedRAMP type customers who needed that. The other thing too is i3 has 10 gigabytes of raw capacity. i4i is essentially double that. Same thing with RAM. The i3 kind of blocked it out there, but it was 512 gig backlights, 1 terabyte memory.
So taking a look at the VMC software-defined data center, or SDDC scalability. For those of you that do have vSphere environments, this is common terminology now for vSphere. We have the ability to scale up to 10 SDDCs in an organization. That can include up to 20 vSphere clusters per SDDC. We have the ability to build clusters that are anywhere from 2 to 16 hosts. And then one of the things that's important to be aware of is that the first cluster in every SDDC is where all of the management components live. These are, again, things like vCenter, DNSX, virtual appliances, add-ons like SRM or HCX management components. Any other clusters beyond the first cluster are used solely for the workloads that you run on them.
Another key note is if you do the quick math, you'll notice that 20 and 16 equal 320. We don't support technically up to 320, it's actually 300 at this point right now. But always, bottom line, always just check the config max at VMware to see what they support. The other thing too, a lot of times we get a question, why 16 nodes? Why not like at least 32? Because we can do 64 in a vSphere cluster. The answer is because it's hyperconverged with vSAN, as VMware is doing management, it does take time to evacuate a node when they bring in another node to do upgrades, patches, that type of thing. So they limited it to 16 just simply for manageability.
From a cluster design standpoint, we've got two different options available. You can have the standard cluster, which provides a 3.9 reliability. This means that there won't be any cross AZ traffic, so all of the nodes would be in the same AZ. And then we have what we call stretch cluster, which allows you to essentially create a stretched version across availability zones. Comes with a 10 petabyte per month at no additional cost. It also brings with it 2x the cost for the actual service. And when this is in operation, the idea is that it provides synchronous writes to both sides. So it brings the availability up to 4 nines.
With this, we also support individual VM customization, meaning like you get 2 SQL servers, active, or something like that between both AZs. You don't want 4 copies of your data, right? Necessarily. So you can actually say, hey, this virtual machine, don't replicate the data. So you can pick out individual VMs to do that with. So there are definitely use cases for that.
Yeah, so Greg had referred to this earlier, Elastic Disaster Recovery Service. For those of you that work with vSphere or have worked with VMware products for a while, you know what disaster recovery service is in a traditional sense. EDRS is not the same thing.
Distributed.
Sorry.
Yeah.
Elastic Distributed Resource Scheduler. This is new for VMC, and it is used to is a policy used to determine how clusters scale out and scale back in. There's 4 different types. As you can see, the default is driven only by storage utilization. All of the rest are driven by some combination of CPU, memory, and storage utilization, depending on what your needs are for the cluster.
Yeah, storage is default. You can't turn that off. So if you reach 80% of storage capacity, we automatically grow. So like pretty much any storage array, once you hit 80%, you can have performance issues in the environment. The rest are just different use cases. If you want to, they're optional whether you turn them on or not, but when you hit certain levels of CPU and memory, you can optimize based on cost, performance, or rapid scale out for times like, for example, VDI. Everybody comes into work, Monday morning. I just want to go ahead and deploy, have 5 nodes add to my cluster all at once.
So how does VMC handle things like host failures? That's obviously, from a resilience standpoint, that's obviously an important consideration. There's automation that's built in. So in this case, if there's something like a host failure or even a degraded host, it's identified within like a few minutes. And what happens is a new host is automatically rolled into the cluster. There's nothing that you have to do. And then the data from the host that's having the problem is automatically migrated to the replacement host, and the host that had the problem is removed from the cluster. There's no additional cost for the extra host that gets added. And typically the process takes 30 to 45 minutes from what we've seen. Again, this is kind of a marketing slide. If I give you my opinion, right? So the idea is by automating and making sure that all of this is resilient, we allow you to focus on the things that are important to you, right? And VMware is responsible for maintaining the underlying infrastructure. That includes things, as I mentioned, updates, upgrades, patches for the SDDC, all managed by VMware. There's nothing you have to do for that. There are some constraints that come with that. For example, those of you that have been used to accessing your ESXi hosts, like from the console, that's no longer available. Same thing with the NSX virtual distributed virtual switch. Those things, because they're handled by VMware, there's no need for you to even access it because VMware's taking care of all that.
Yeah, it's kind of funny. There have been some customers I've interacted with that have been like, hey, how do I get in this? How do I get in that? Just send VMware support ticket, right? Right in the console, you've got a little question mark right at the top. You can either ask them a question directly there or submit a ticket, and they'll take care of it for you, or you provide you the answer as far as like performance metrics, that kind of thing. William Lamb has some things on his site too that kind of help you out getting access to some of those things that you used to have access to. There's a couple tools that he's had some blog articles on about how to regain that type of visibility.
Yeah, so we talked a little bit about there being some different storage types available. Back when VMC on AWS was first released, all you had was vSAN. Well, the message the customers gave back was, we need more flexible ways to scale storage and hosts for CPU and memory independently. So over the last few years, there have been new storage options that have been added all the way on the right. So FSX for NetApp ONTAP has been added, that's NFS, and then VMware Cloud Flex Storage. Are we doing on time? Yeah. All right. There are some small differences when you take a look at things like the reliability, like the number of nines. The performance is slightly different, but it does give the flexibility that you can now scale your storage independently of your host, which can help to optimize your costs associated with running your SDDCs.
Yep. Typically, I've found between like a 25 to 50% cost reduction in total SDDC costs. They've got a customer out in Oregon where initially they were 7 i4 nodes, and we brought in, they're actually going to use FSX for ONTAP solution, and it actually dropped it down to 3 nodes, so thereby reducing their total cost by 50%. So we can scale, as Marshall mentioned, storage independently of compute. A couple key things: the VMware Cloud Flex Storage that was essentially the Daydream acquisition that VMware made a couple years ago. So that this is the technology that they purchased. There's one data store supported now, minimum's 25 terabytes. So cost of entry, it's not too bad. I mean, the storage is relatively inexpensive from considering what a host cost would be. Maximum size is 400 terabytes. On the FSX, there's smaller minimums, essentially 1 terabyte. You can spin up something about that small. As far as the maximum capacity, it's whatever that solution supports, which is potentially multiple petabytes, potentially even in different volumes. We can mount up to 2 volumes for that. It's also currently single and multi-AZ supported, so if you're looking at something that's more resilient, you can look at that. CloudFlex storage, that is in the roadmap for it. I don't have any dates though. With ONTAP, we can support multiple SDDCs, multiple orgs with that solution. The key thing, however, is it does require what we call a transit gateway. Transit gateway in AWS terms is essentially a regional router, and there can be data processing charges in that. So you have to think, there's no extra charges with CloudFlex storage. It's all completely managed by VMware. It's just a simple per gig cost. With the FSX ONTAP, currently that TGW has to be in place. VMware is looking at trying to find ways to remove it while maintaining a fully managed service. That'll be one of the things we'll take a quick look at in the demo tonight. Yeah, this is essentially what it looks like here. So this would be a multi-AZ FSXN deployment. We've got a VPC that crosses 2 availability zones. We've got what we call an ENI, an Elastic Network Interface. It's basically the interface that connects into the storage. And then from there, within the SDDC, we actually have 2 ENIs within that customer AWS account that connects to it. We'll connect that through what we call a Transit Connect. A Transit Connect is essentially a VMware managed transit gateway. So this is it's passed through as far as payment, but it's managed inside a VMware managed account. We'll take a quick look at that as well. And then from there, we're coming over into the SDDC, and we can either use it as an additional data store, or we can still present it to our virtual machines. So our virtual machines could actually use block or file storage from that solution.
So one of the things that I've heard from customers on a regular basis is, okay, so what do you do about the data you're storing on the SSDs that are connected to the hosts, right? Well, we encrypt the data by default using AWS KMS for control of that. All data that is stored on the vSAN SSDs, excuse me, are completely encrypted at rest.
Yep, so two levels of encryption, on the SSDs at the physical level, and then AWS Key Management Service. And then you can even provide your own keys to the operating system, like the operating system you install. You could have those encrypted too for a total of three levels. Let's get that. Let's get into this. Build that out.
From a connectivity standpoint, this is probably the area that customers have the most questions. There are 2 primary ways that you're going to connect your data center to your VMC SDDC. The first is going to be VPN. This is typically going to be lower bandwidth as you would expect, but it is secure. The other is direct connect. So you can see here, the way that works is you connect your router to the AWS virtual gateway, and then that is connected into the NSX edge, which is called the T0 router. And then you have 2 separate gateways that are connected to that. One is for the management cluster, which runs all of the management components inside of VMC. That includes vCenter, that includes any of your HCX management components, all of your ESX this is where your workloads would normally live.
Just quick note, and we won't get into any slides relating to this, but just quick note, we can support multiple compute gateways now. We've been able to do that for about a year. So we can have up to about 200 of those. And then with the network segments, obviously this is like your standard traditional routed type. We support two other types now, isolated and NATed. So key use cases for those is I actually have a couple customers that do malware testing. So they'll use like the isolated ones for those, or you can do like DR testing, right? So obviously you don't want those IP addresses if you fail over and don't change the IP addresses in those machines. You don't want those affecting the rest of your network. So NATed or isolated for those.
So then, taking a look at the connectivity between the hosts that are running, that all of your workloads are running on, from a design standpoint, each one of them has an ENI that is tied to your customer-owned AWS account, and then the hosts are, if there is any kind of a failure or degradation, the connection to the NSX edge and the host is then replaced automatically by a separate host. I believe there's 16 ENIs that are 17 now that are created automatically. So from a resilience standpoint, this is completely automated. You don't have to do anything. This is built into the product and is established at the time the SDDC is built.
Couple key things. The account where the hosts are deployed into is actually a VMware owned account. These are dedicated per customer. So from a security perspective, they're dedicated and tied to you as the customer. The customer owned AWS account, this would also be the same as the biller account. So that's where the billing would run through whatever AWS account number that would be aligned to.
You want to go ahead?
Yeah, so this one's a little bit pretty busy. I'll break it down a little bit real quick. So we've got numbers of SDDCs here on the right side in orange there. We've got the VMware Transit Connect, which is the regional routers. These are being peered together. You can see there's two different regions, region A, region B. Let's pretend it's like North Virginia and Ohio or Oregon in those terms. And we created what we call an SDDC group that automatically deploys what we call the VMware Transit Connect, basically the VTGW routers. These are paired together. So think about multiple vSphere environments or multiple environments being connected by routers. Right from there, if you have existing AWS or when you would need to have additional VPCs that are tied with that infrastructure, you can create additional AWS transit gateways within your own accounts. And then these can be paired with the VMware Transit Connect so that you can have all that communication between the SDDCs and your native VPCs. And then from there, the AWS Transit Gateways, they support VPN connectivity with ECMP, so for redundancy's sake and bandwidth, available bandwidth. We also obviously support Direct Connect directly to those as well from on-prem. So this would be a way that you can connect to within the environment without having multiple connectivity points. Obviously, we do support also the new SD-WAN technology that AWS has, where you can peer into one transit gateway and then get access to your entire environment across multiple regions. Any questions on this one? I know it's kind of a busy slide. Okay. Let's see, let's skip some of this stuff. I'll actually jump into the console here in a moment. We'll go through some HCX stuff. So basically, this is one of the really cool things about VMC. It's included with the service, but we call it hybrid cloud extensions. So.
Oh, yeah. Hybrid cloud extension, one of the most difficult aspects of getting your workloads to the cloud is migrating them over. With hybrid cloud extension, you have the ability to actually move your workloads as they are, right? So with native public cloud, a lot of times there's going to be replatforming, refactoring, those kinds of things to make them work correctly. Because this is vSphere, HCX has the ability to do things like cold migrations, vMotion migrations, and even scheduled migrations for your workloads. And it moves them as they are and allows them to then run in VMC just like they were running on-prem.
Actually, I had a customer, they had 4 Windows 3.11 machines. They used to, they would play lunchtime, they would play Doom. And they had these sitting there and like, wow, I wonder if these would actually work in VMC. So they migrated them and they did. So it was actually pretty cool.
We also have something called HCX Replication Assisted vMotion, which is, I'm assuming, what your customer used, which allows you to install an agent inside of the operating system to help provide greater support for some of those edge case operating systems that may not be as well supported.
Yeah, the bulk migration and HCX Replication Assisted vMotion, we call that RAV for short. Those allow you to do up to 200 virtual machines at once in one migration wave. Bulk migration is very similar to your old P2V method where you replicate the data and then in the scheduled time shuts them down, finishes the data copy and boots them up in VMC. The no downtime options, they allow you to migrate, like I said, with no downtime. Typically you miss one ping. We'll look at a demo on that real quick. But the bulk migration and the replication assisted use vSphere replication to move the data. vMotion is just your standard vMotion type migration.
So here is a more detailed view of what that looks like. So as Craig was describing, your cold migrations do involve downtime. And this is the amount of time it takes from once the VM has been replicated to VMC, it's then shut down and turned on at the destination, right? So it's roughly equivalent to the time it takes to reboot a virtual machine. vMotion, for those of you that are familiar with vSphere, that is live migration, as in there is no downtime. As Craig said, there might be like 1 ping. Worst I've seen is 2 when everything's working as it's supposed, configured and working as it's supposed to. The bulk migration takes sort of the cold migration and allows you to increase the number that you're able to do and orchestrate a large number of VMs being migrated at one time. It does require, as I said, like the cold migration, some minimal downtime. Once they cut over, shuts down the source, turns on the destination. For the replication assisted vMotion or RAV, there's no downtime with that. Again, this is similar to what you would see with vMotion, except now with vMotion, it's going to typically be single VMs that you're moving. With RAV, you can move groups of VMs at the same time. And then for the OS assisted migration, there may be some conversion involved but it allows you to move from other hypervisors, even like KVM and Hyper-V.
Yeah, this is your agent based. So you install an agent, and that's how we support KVM Hyper-V. VMware is working on a physical one. I've heard some customers, play with that a little bit with some success. But officially, VMware doesn't support that yet. Like I said, they've been working on it, but no dates as far as when they might come out with that. Key thing is we still limited support vSphere 6. It went end of life October 15th last year. However, with HCX, we do still have limited support for that release. But obviously, we fully support vSphere 7 and 8. The other key thing too, I'll just mention with the live migration methods, we do require at least a VDS, a vSphere distributed switch on-prem. But the rest of the stuff fully supported. We really don't care what kind of storage you have. we're leveraging that hypervisor and the intellect there to facilitate those migrations. Yeah, the keys.
Go ahead.
Yeah.
Wise.
Yep. Yeah, we should probably move forward with demos. There's a ton more content, so if you're interested, we can, definitely take it offline if you're interested in seeing more things about it. But for now, let me go ahead and jump into our lab environment. Just give me one sec. Go ahead and.
While Craig's getting that set up, does anybody have any questions about VMC so far? The information that we were showing in the slides?
No, what are some typical value statements around this model? So I'm trying to think of maybe, why a current VMware customer might choose this. It sound like, one benefit might be to abstract the hardware layer, the management layer. That sounds valuable. But what are you guys hearing from other customers? Why they're choosing this?
Yeah, honestly, a lot of different reasons. I did kind of skip all the use case ones. Data center expansion, right? Just need more stuff, can't get the hardware fast enough. Here, we can have you online and running with an SDDC in less than 72 hours.
Okay. Right. Do you see customers that are doing like maybe kind of an active passive type situation where
DR, definitely DR use case, full migrations. Large insurance company I've been working with, they migrated one of their environments. The hardware's 5 to 10 years old, and they didn't want to replace it. So they're like, hey, let's use the cloud and maybe use this as kind of a blueprint of what we might want to do with the rest of our data center.
Okay.
And so they took an environment and actually that data center, I've been working on it now for, it's been a year and a half. They're going to close the data center at the end of this month. About
they're running
20
solely on?
Yep. We used mostly VMC, probably 90% workload there. Typically, when I see customers with more than 1,000 VMs, there will be some native component. Like for example, they've got a PCI environment, and it was too small to warrant the cost of 2 or 3 node VMC environment. So they had to, and we do support PCI, but they just chose to use put those in EC2. I've seen, full data center exits. Just we don't want to maintain the hardware anymore. That's a big portion. And then typically with that, they'll bring along DR solutions.
Something else I heard customers talk about is, hey, we have workloads running in AWS native, public cloud, or there are services in public cloud that we want to be able to access, and trying to do that from on-prem, sometimes from a performance standpoint or complexity with some of the networking. By moving the workloads up into VMC, you're adjacent to those services and you have access to the AWS backbone, which is obviously very fast, low latency. So it gives very easy access to those additional services as well.
Okay, no, that makes sense. Thank you.
So the DR issue is one that we're facing at Kentucky Farm Bureau. We have offsite VX block up at Indiana Farm Bureau.
We've talked before.
Yeah, and so the support for that goes up January 2024. And so as a cloud person, I'm looking at this as a transition to the AWS cloud, because we don't necessarily have the resources to dedicate towards refactoring or rehosting things in a native EC2 type of environment. So we're looking for a solution to address our disaster recovery first. And this might be, well, let's do this to address that hardware problem, and then we'll get our people skilled up in refactoring and re-architecting, et cetera, like that. So,
It's a cool way to get into the cloud without having to learn everything about it, right? There are some things you have to learn, right? Especially in the networking piece. This is the same vSphere stuff that you're used to on-prem, as I'll show you here. The key differences are what Marshall pointed out before was networking, right? So it gives you time to kind of ease into the cloud model, the cloud networking model, if you will. So it kind of helps customers from that aspect. We do often say it's the fastest path to the cloud because you don't have to do anything with your applications. You just pick them up, move them over, and drop them in. There are some networking things that you do have to consider, right? Especially if you have on-prem physical firewalls. I went through with another customer. They had 2 Palo Altos on site, and they had a physical cable between both of them for failover. Obviously, in the cloud, you don't have that physical cable, so it's hard to get those, half a second failover times because there's no link that goes out if your cloud firewall, dies for some reason. So there's those types of nuances that a lot of customers do have to ease into, but it's a lot easier if they don't have to relearn, go learn EC2 and all these other technologies first. And then allows a customer then, because it's sitting on the same infrastructure, you're half a millisecond from RDS or S3 or EC2 or, one of the other 200 different services. Yeah. So this is what we call the VMware Cloud Console. There are typically 2 consoles that we work in. This one primarily from a VMware perspective. And then obviously we've got our native AWS console sitting there. Within here, we've got access to, different types of services that we might want to subscribe to. One of the key ones, obviously, looking at is the main VMware Cloud on AWS service. So we'll just click in here. As you can see, there's a lot of things on the left there as far as billing, subscriptions, roles. This can also, does support enterprise-based authentication. So you can integrate like Okta and those types of things as well into this console. I'll run you through real quick how to actually build an SDDC. So if you think about, say a VxRail stack with VMware Cloud Foundation, how long that might take to architect in your data center. As I'm going through this, think, okay, it's going to take me that long to architect that and build it on-prem versus what we're doing here. So we'll do create SDDC. Give it a name. We could just do test. Deploy it in any one of our 23 different regions. So this is an easy way to go globally fast, right? That's another potential use case. Hey, I want to go into another region, another part of the world. I can do it in a few minutes. We'll just put it in Ohio. We do support single host for up to 60 days, and then it gets deleted. There's no SLA. We often do it for labs and demos and stuff. Multi-host and then stretch cluster. Still choose i3, i3EN, or i4i. Number of hosts, we start off with 2, 3, or 4, and then we can expand from there once it's built. Next, pick an account. Obviously, this is a demo lab account, so we've got a lot of accounts in here. If you don't have an account tied to it, there is there's a script in here, so we can connect it to a new AWS account, and then it runs a CloudFormation template right within there. This is documented, so there are some permissions that it has to tie to that account, particularly to deploy those Elastic Network interfaces. And for security reasons, they are well documented as far as the exact process that VMware uses for that. So once we pick the account, next, we're looking now for that, one of those VPCs that are tied to that account within that particular region. So if you think, okay, where do I want to place my SDDC? Wherever you place that VPC, and then the next choice you'll see is that subnet. That subnet defines which availability zone this will be deployed into. So I do have a VPC here, and I do happen to have some subnets. Next, this is the management CIDR. So this is key for the management component, so it's got to be unique to your environment. Obviously, for management purposes, you want to be able to route to it. You can see there's specific definitions as far as how many nodes you plan to support. This is one of those things that we call a one-way door. Once you pick it, obviously it's very difficult to change IP addresses in a vSphere infrastructure. So we get a /23, /20, or /16. This is not coinciding with the other network segments that you're going to add your workload to. Those could be any networks that you want to either migrate or just use. And check the 2 checkboxes, says, yes, I'm going to pay my bill. And then click deploy. Typically it takes anywhere between 90 to 120 minutes, and now you've got a usable SDDC. Adding hosts, if you do 2 nodes, typically takes about 45 minutes to add a third node, just some back-end stuff that VMware has to do. In a 2 node, there is a witness node that actually is deployed in EC2. But once you get to 3 node and on up, adding additional nodes typically, like I said, in little as about 12 minutes, you can add capacity. Click deploy and that's it. From there, let's go into what an SDDC looks like. So we go into our workshop group. These I'm switching different organizations. This is our what we call immersion day environment. So we give immersion days for different customers within this. So I just used our immersion day template. So I deployed this Sunday morning using a Terraform script. So I deployed one node in North Virginia, another node in Ohio. So I've got 2 SDDCs, created an SDDC group. So it made that transit gateway for me, that virtual router, so I can route between the 2 environments. And then also deployed HCX for me as well. And then also deployed a number of student virtual machines for me. So bottom line is, we can use infrastructure as code to deploy all this stuff. This is the main console to the software-defined data center, SDDC. We've got cluster here. I can add hosts. I can edit different things, attach a data store, edit Microsoft licenses. So we can leverage VMware SPLA for Microsoft licensing, primarily for Windows Server. Networking security, I won't go step by step through all this stuff, but this is where we configure additional segments, NATs, VPNs, additional tier 1 gateways. We've got our security components here. So within NSXT, we also support what we call an advanced firewall. So this is layer 7 filtering right within the virtual networking. These are different groups, inventory groups, so we can create service groups, groups of services, groups of like IP addresses, VMware tags, that type of thing.
How would you connect it to an existing on-prem environment?
A couple different ways. I can show you either some architectures. We would either do a direct connect or VPN.
Okay.
That's the VPN up here. We've got a direct connect thing here. However, especially my larger customers, they'll tend to use a transit gateway. So the AWS regional router, they'll connect to that and then peer that to either directly to an SDDC or go through an SDDC group. Because often they'll leverage other AWS environments, other VPCs that they'll need to peer to as well. Some of the use cases for those other VPCs are service related, backup type services, might use security VPC where we're forcing all traffic to go through like a Palo Alto or something else. Or just simply EC2 instances or even some other functions.
One of the things I'll touch on for security, because I did a lot of NSX in a previous life, that is whether you're using it on-prem or in here, but even more so here in VMC is I had a lot of customers say, our compliance requirements are becoming more and more strict, or we've enacted new corporate policies that require us to do things like microsegmentation. NSX is built for that, right? So as Craig said, not only does it support north-south, which you would typically see on an on-prem type of a firewall, but it also does full east-west control. So it makes it really easy, relatively speaking, to do things like microsegmentation. And there's also some other integrations, as he said, with the advanced firewall that allow you to really leverage that capability without having to do the kinds of complex designs that you use to on premises with physical hardware.
Let me go through the rest of these real quick. Support.
Direct Connect and Transit Gateway that you all use for this isolated from maybe a different one? So we already have a Transit Gateway and a Direct Connect. Is this one dedicated solely for?
We can, and that's often the case. Customer already has an existing one, so we'll leverage that one.
yeah, as long as the,
Yep, just
as long as the
the bandwidth.
bandwidth
Yep.
is there, okay.
Exactly. This is our support information, org ID, SSD, version number, that kind of stuff. This is where we get management information, vCenter information here, fully qualified domain names stuff. I'll point out one thing here is a lot of customers are like, hey, we've got a public IP address on our vSphere, vCenter server. That's like really, really bad, isn't it? So we say, yes, it is. You can switch to a private IP only. It's still resolvable by the same name, but it can only be accessed via that private IP. Do the same thing with HCX, Hybrid Cloud Extensions, our migration tool. Same exact thing, and then also NSX. You can see some handy little connection scripts for either PowerCLI, API, and our standard HTML5 piece. Troubleshooting, connecting to on-prem so we can do integration, tie the vCenter so you're using enterprise authentication with vCenter as well. Leveraging your existing groups, that kind of thing. This is just a test place for that. Any type of maintenance task that VMware's going to do, you'll get an email of the accounts whoever has account information in here, or they'll pop up here. You do have a chance to defer those as well if they're non-critical. Integrated services, if you want to leverage any of the other services, you can activate them right here, or just simply if they're already activated, just open the management pane. One of the key things I did want to show you, this is that additional storage piece. So I have set up the FSXN, another volume here. So if we want to add, we do attach data store, opens it up to another console. Simply pick the cluster, the actual attach new data store, pop in the IP address, and I'll show you how we get that and what we do with FSXN. And then that'll automatically add the actual path that we're going to mount, and then the particular vendor, which in this case is the FSXN. Name it, and that'll attach it to our entire SDDC. Not like us having to go to each host, right-click, add NFS data store. So this is a way to do that. How we set it up within the AWS side is we would go to up here to services, go to FSX, back in. From here, we would essentially build an FSX and data store. So it's as simple as creating a new file system. There's some details to go through within that. We're setting like the cache size, the amount of bandwidth that we want to allow there, and then of course the volume sizes. It takes about roughly 20 to 30 minutes for one to be built. And then from there, the VPC we're attaching it to, we just have to ensure that it's accessible via that SDDC. And I'll show you real quick how we do that as well. But I've got this one created here. We would click inside this, and that'll actually give us our specific IP address to hit that storage, the storage supervisor. Once we've done all that and created that connectivity, we would go back to the console. And right here within the SDDC groups, I would go into the group here, and I've got an external VPC access. And so what I would do is I would add that particular AWS account within here, ensure I've got connectivity. There's a few routing things and things to do like that, but once all of that's set up, at that point, we just go back and simply connect to it from that console. So this is how we add this additional FSXN. The VMware piece, the Cloud Flex storage, that would be added a different way. There's a separate console that VMware created to expand that. The other note about the Cloud Flex storage is it's actually been in production for a year. It just went GA about a month and a half ago, but it's actually been in production supporting our VMware Cloud Disaster Recovery solution. So it's been the back-end storage replication target for a year. That was GA a year ago. And so VMware used it in that capacity for the past year, recognized that yes, it is very performant, and said, hey, let's actually integrate it as a supplemental storage. And then probably I would say, at some point it's on the roadmap that it may actually become primary storage, potentially replacing vSAN. So then that would be the ability to really disconnect that compute and storage layer and potentially offering more node types. We are also in this SDDC group, we have the ability to access the external transit gateway. So this is where we would do that peering between the VMware Transit Connect and the transit gateway within the customer account. We can manage routing policies between those. We can actually inject prefix lists into other AWS accounts too. So a prefix list, think about it as it's an alias with a list of IPs or subnets in there to allow management of other environments much easier. So as we create, say, additional network segments in the SDDC, they'll automatically get populated within the prefix list. And then from there, they can be attached to, other EC2 instances or other objects within AWS to do some automation. From there, you'll see, I'm gonna go ahead into the vCenters now to show you. We've got, let's see, let's go this one. So we've got our standard vSAN data store. This is the VMware owned one. So this is the management one. We don't have access in there. We use the workload data store here. This volume 1 was that NFS data store that we mounted. So it just shows up just like any other data store. And we could do storage vMotions between those. I can go over here to one of my virtual machines. Let's maybe pick student 5, for example. I can do right click. Migrate. I'm going to change the storage. Next. I'm going to be able to pick volume 1. Next. Let's say change store default. Let's see volume 1. Data store default and provisioning. Oh, insufficient space. I made that one too small. Yeah, so it's only a gig capacity. Yeah, so it's too big, but I could do a storage vMotion over to that one. One of the other things too, just show you some more of the integration between an SDDC and native AWS. One of the other things I did, let's go ahead and reload.
Quick question for you while you reload that. I guess, are we still paying a lot of the ingress egress costs as we vMotion between the on-prem and the VMC?
You only pay for egress.
Okay.
Their ingress costs are 0.
Okay.
Just as long, you've got to consider if you're going past like a transit gateway, you're going to have those data processing charges, but there's no charge for ingress data.
Egress from AWS to your on-prem if you're vMotioning back that direction.
And that's typically based on region. If you're using VPN or internet, sometimes those costs are a little bit higher. Direct Connect's a little bit less.
Okay.
That side. From here, one of the things
So say you have your organization in one account. This is obviously in a different account. Hey, I'm talking AWS organizational level. So even though it's across the backbone, you're going to be charged egress there, right?
what do you mean between
So like,
two?
I'm saying the vMote, you create that FSX in one AWS account. But
Yeah,
the
it's not-
vCenter is in a different AWS account, right? Even though.
Yeah, so the accounts, you're not charged between two accounts, you're charged through just simply the TGW. Because the TGW right now has to be that attachment point. In the future, at some point, VMware will be able to remove that TGW, so there won't be a necessary component. So I'll be able to take that FSXN data store, put it inside the connected VPC, and then that connected VPC, I'll be able to mount it directly from that, so I won't have those additional charges. Yeah. So like, for example, with the Cloud Flex storage from VMware, right now there's no TGW charges.
Isn't the FSX isn't the traffic flowing through the transit gateway to get to that FSX?
Yes. Yeah, currently it is.
So you would be charged egress coming out of the transit gateway to that.
It's not really egress, we just call it data processing, so it's data that processed through the TGW.
So you're gonna get your TGW charges, but
Yep.
not the other.
Yeah, there's two charges in a TGW, there's the attachment fee, which is pretty minimal, and then there's the per gig cost. On average, we've found, based on how much the FSXN cost you, we're finding about 10% of those costs on average is what your TGW bandwidth charges are per month. So it's about a 10% on average. We generally, at least right now, we don't recommend you throw like some 50,000 IOPS SQL server, you know, on FSXN until we get rid of that. Maybe look at the Cloud Flex storage or something like that. You know, it's good for large file servers, data warehousing, that type of stuff. So here is a ALB, so load balancer, that I created, configured. This actually is going between two availability zones. Within here, I've actually got a couple, let's see, my target groups. I've actually got a total of, I think, 6 total IP addresses within this that I'm targeting from a target group perspective. So these are all IP addresses that are sitting within the SDDC. So I'm leveraging one of those other, you know, native AWS services, which with the ALB, application load balancer, I can actually use our web application firewall technology and tie it to that. So a way I can leverage and maybe not have that, you know, maybe F5 expense sitting there, could leverage this service because there's no licensing fees for it. It's just data transfer for this. And so these 5 IP addresses I actually have over here. You can see this student Linux 01. I've got a .43 sitting there. I've got my .43 sitting here. So I'm leveraging this load balancer. I'm actually going to student 1 Linux all the way through student 6 Linux for these. And we can see proof from that from this web page. So it's just a basic little web page, and we can see every time I refresh, I'm just doing kind of like more like a round robin type of policy right now. And the load balancer just displaying the IP address of that. But I'm going through, as you can see in the top screen here, I'm going through an Elastic load balancer for that. So again, in this case, I'm using the connected VPC, so I'm not going through a transit gateway for this one. I'm just using the connected VPC for this to be able to create that. Any questions? One of the last things I want to show you, I know we're kind of running a few minutes over, but HDX console. So HDX, again, is our hybrid cloud extension. It's our migration tool. It's included with the service. You don't pay any extra for it. This is the main dashboard. You can see there are 2 sites. Like I mentioned before, we've got North Virginia. It's my SDDC-A, and we've got SDDC-B on-prem sitting here. Site pairing, one of the first things you do once we get the software installed, there's a manager that gets deployed in the SDDC. There's an HDX connector that gets deployed on-prem. And then we create a pairing between these. Can go through a direct connect, can go through a VPN. Really, that's up to you. From there, we go into, we start creating the interconnect. So there's some network profiles that get created. And what this does is this creates those mappings that are on-prem, where we deploy our virtual appliances into that actually manage the migration piece from that. And create those profiles. They define, you know, how the connectivity operates from the SDDC to on-prem, and then also facilitates what our on-prem environment looks like. Like where's the vMotion network, right? You don't have to change your vMotion network. We just need to know where it is. We might have to put an interface in it, or you might have to make it routable. Other things like what's your distributed virtual switch look like, and what network extensions do you want to create? So we can create layer 2 extensions from on-prem to VMC. so you don't have to change IP addresses. Same broadcast domain. So all of those things are defined there. Once we've done that, we create what we call compute profiles. This is where we actually deploy those service appliances into. And then from there, we create a service mesh. This mesh actually then builds the tunnels that facilitate the migration. So you could think about these appliances simply as proxies, so you don't have to change anything on-prem or even potentially even risk security. I've had a couple customers where they're in fully managed environments in another cloud provider. And the cloud provider has allowed them to go ahead and integrate, deploy HCX in the environment, but the cloud provider is actually doing it. And then the customer then can have unique permissions, limited permissions, to be able to then facilitate the migration of their virtual machines. So we can do things like that. Without going into too much detail, for a migration here, and what I can typically do, I'm just going to click migrate. Typically as part of the demo, I know we're running short on time, but as far as a demo, we can pull 2 virtual machines from each location, start a ping from both of those, watch the pings, and as soon as we see the migration complete, the ping times will change. And typically we only lose about a ping in that. So come into our SDDC, kind of look at our resources. I've got a bunch of student VMs here that I can use. I'm just gonna go pick a Windows machine. I'm gonna add it to the queue, so we could pick multiple ones if we wanted to in this to form a migration wave of multiple VMs. In here we pick what our destination looks like, as far as where do we want it to migrate to. So we're gonna pick the compute resource pool in our SDDC. We're gonna specify a particular folder. Actually, we've got to choose workloads. Storage component, so we're gonna pick our workload data store. We can change the format. Typically with vSAN or some of these other cloud solutions, thick provisioning doesn't really benefit. Really, we kind of saw those benefits go away once we got away from your traditional, 5-drive RAID 5 type of arrays. So this gives us an opportunity to maybe force thin provisioning. Here we're just going to do the same as source. And then here we can choose between vMotion, bulk migration, or replication assisted, being the VM was powered up. So it's giving us those 3 choices. Bulk migration, especially if you're doing more than 5, typically use that, or the replication assisted vMotion. Keep in mind that vMotion portion of RAV is serial still in nature. The bulk migration piece, the replication assisted part migration, is parallel. So I can do up to 200 at once, but then the cutover is serial. So you just have to consider that. Not great for virtual machines that are super busy, like 10, 20,000 IOPS. Probably wouldn't recommend the vMotion portion. I might want to do the bulk migration for that because I want it to shut down. I want that IO to stop so we can finish that replication or finish that move. For single VMs or a couple VMs, vMotion is the fastest. Serial, but it's fastest. We can choose to schedule, like Friday night at 9 p.m., right, during an outage window. You can also change that at any time, even during while the migration's happening. A lot of customers will start at Monday, replication will finish Thursday, do some math, figure out when it's going to finish, and then finally do the cutover, schedule the cutover at Friday or Saturday. Here we'll just do ignore, apply, and then from here, click validate. Oh, we got an error. So in here, our error is cannot proceed. One of the VMs have an issue. And here I haven't mapped the networks properly. So what I can do is I can come down here and actually change the particular network that we want to migrate into. So here, I'm just going to pick one, click validate again. And now we've got success. So it kind of just checks my math. It goes through and checks all the settings, make sure, they're valid. And then I'm going to click go. And it'll start migration. From there, I can watch the migration. I can watch the events in the console here. Takes a few minutes, but eventually I'll start seeing some events stack up. There's also some other pieces in here, some analytics that I can go look into, where it'll actually give me, how much data am I moving across the wire between the two sites, so I can watch some performance things in there too. There are some test procedures you can do right when it's deployed, or if you change, say the direct connect, maybe direct connect bandwidth, or you move from a VPN to a direct connect, to kind of anticipate how much workload, could I migrate essentially in one migration wave. So there's some analytics that VMware built into. A lot of those this is currently HCX, what we call HCX 4.6. A couple versions, I think it was 4.4. A lot of those analytics and additional tools came into play.
So that's pre-migration, so you're able to figure out what the bandwidth cost might be.
Not cost, but
Well, okay, yeah.
yeah, the amount that you could potentially migrate. Yep. So yeah, that's pretty much it. So this one VM that we're migrating, eventually the student O2, we would see it migrate. So it's this machine here. We can see that we've got some stuff starting to happen. So eventually this machine here will end up over into this other SDEC. So we've got this one here that exists in Ohio, this one in Virginia, North Virginia, and this one exists in Ohio. So we would essentially see it move over into this workloads folder. Takes about roughly 10 minutes for a single VM of this size, maybe a little bit more, 15 minutes. Yeah, that's about how long it takes. Any questions?
Easy.
Yeah. Yeah, it is. I mean, that's the thing. I mean, this is, and if you think about it, I'm actually doing a vMotion that's separated by like 600 miles, 700 miles. So a number of years ago, I think it was vSphere 5. Between 5 and 6, VMware actually did a lot of work in the vMotion technology because you remember vMotions, you can only maintain a latency of like 10 milliseconds. Well, they went from 10 milliseconds to 150. And so kind of those enhancements really helped this. There were a few other enhancements too, especially with NSX, with VMware creating multiple TCP/IP stacks that actually help this process as well. Depending upon different customer environments, I've had to architect HCX and its deployment very differently for certain customers. And having those multiple TCP/IP stacks sometimes has helped as well. If they have like different vMotion networks with different gateways that I want to route out somewhere else compared with the management portion of the network. Customers who might have completely separate management domains and then back-end infrastructure networks to support those types of things. So really, the tool doesn't, you don't have to re-architect your on-prem environment to, make this work.
Craig, what do you say to a customer that says, well, I don't want to get in the finger pointing business with VMware tech support and AWS tech support? Is it all the same? Are customers having to maybe spend more now because they have to add additional support for AWS environments? No,
That's where you go.
It's included.
it's included.
Yeah, it's all included. It's right there. You go to VMware. You don't come to us. Now, yes, if you have other AWS stuff, yeah, then you do. But I mean,
But typically VMware
we're really
support
tough.
is gonna broker the communication if they think that there's a problem, like on the AWS side.
Yeah.
And they're empowered to broker those communications on the back end to try and work through problems.
Yes. And really even from my perspective, I mean, I have probably more meetings with my counterpart in VMware than I do my own, employees, my own colleagues. So we work very, very hand in hand. Sometimes we actually work better and we actually lead the conversation from even some of the salespeople.
And after the migration, how much time are folks spending in the VMware console versus the AWS console? Is it majority VMware's console?
Good question. It really depends because it depends how much of the infrastructure and how complex it needed to be and how much you might still need to architect. Most customers, not a huge amount. it really depends on, are they coming to AWS and VMC to stay in VMC, or are they coming to VMC to get there first and then start picking apart applications to put in native? I've had both use cases. Like one customer, they migrated their entire environment, about 2,500 VMs, and the goal of this one particular environment is for them to sunset it, right? It actually went out of service as far as serving their customers in January. And so now they plan on just finishing all the rest of the contracts they have with that particular environment. And then, eventually in a few years, they're gonna archive it, dump it all in S3 and, keep it for however long they have to, from a compliance perspective. But then eventually they'll just let it go. And then they're rolling all of those new customers into their new platforms that are going in. Some are on-prem, and a lot of it that they have is they're looking at other AWS services for a lot of those. But they still have a huge, have probably another 160 nodes on-prem, I think, something like that.
So there's not really a lot more, for somebody that's very familiar with vSphere, there's not really a lot more for them to learn to be able to operate in VMC. It's really just another location.
Not in vSphere at all. You really think about this deployment, it's hyperconverged, think about VxRail plus VCF, and it's a consolidated VCF architecture. There are use cases where we'll dedicate that first cluster just for management, because that T0 edge appliance does reside in there. And there are things to think about when you're pushing, say, 10 gigabits worth of throughput through that T0, to think about how many packets per second you're shoving through it. But things like that, I mean, you would typically know, and then the rest of the clusters, are used for your other workload. Like I'm working on an architecture right now, customer with its Citrix environment. They're looking at 45,000 desktops. And that environment will have a dedicated management network just to support that amount of bandwidth. Obviously not going all into one, SDDC, but yeah, we definitely have to consider how much bandwidth they're gonna be pushing ultimately. They'll have another dedicated cluster for the Citrix management components, and then the rest of the clusters and SDDCs will be for the VDI instances.
Are you seeing any kind of hesitation where customers are looking at this and going, well, wait a second, my compute now is running in a VMware owned account, it's not in my account? Is that?
Yep. It's definitely come up. One of my customers actually asked that. It's like, hey, what does VMware have access to, right? What do they have access to? Because they're managing the account, right? They're able to do upgrades and all that stuff. Short answer is they don't have access, right? They said, well, surely they do because they have admin level rights. How can they avoid it? For that, VMware does have SOC 2 reports that you can get access to. I think you have to sign an NDA and stuff. I've helped a couple customers out with that. But yeah, you can get those reports. I mean, it supports DoD workload. It's in GovCloud. It's FedRAMP. So there's definitely a lot of those things, a lot of those security policies and stuff behind it, and attestations. The key thing I will say relating to that is the AWS documentation and attestations does support the VMC architecture, but VMware uses that. So for VMC, you go to VMware for those attestations. So we support PCI, we support, GDPR, we support all those different types, so.
Actually, you just kind of brought up another question for me. For a control tower environment where they're using SCP, service control policies, or any kind of permission sets, how are those being applied to a VMware account?
They wouldn't be applied in this. You could apply those to the connected VPC, but not within VMC itself.
So how could you prevent a user from spinning up VMs or VMs of a certain type, for example? How would you control that?
It's
The way you do
VMware
on-prem
policies.
today.
VMware policies at that point. Yeah,
Okay.
yeah, it would be vSphere then, at that point. Yeah, I mean, you can't update hosts, but you have full control over your virtual machines in VMC. Whatever you do, what networks you plug them into, all of those pieces.
So the question, would there be a cost difference between one, having multiple clusters under one SDDC, or two, having multiple SDDCs with one cluster each?
Good question. The key thing there you have to think about, even before cost, is where do you want your network boundaries? NSX, your network boundaries across the entire SDDC. Okay, so if you want to keep the same networks, you would want to run the same SDDC. Use case for that, obviously your standard use cases. Use case for having multiple SDDCs would be, I've got production, I've got non-production, right? I have to have those routable. So that's kind of the first thing, is just understanding those boundaries. As far as the cost, with each SDDC, you are kind of paying for the management components. So you're talking roughly about 1 to 1.5 terabytes of storage. You've got some compute in there, depending upon, you know, how many additional services you deploy. You know, it might take up more storage, more compute. So you are supporting that first environment from that perspective. Plus, even within a same SDDC, 1 cluster versus 5 clusters, right? There's redundancy you have to buy into as well. So if I have 1 cluster that's 3 nodes, my minimum cluster count's 2 nodes. So if I want to create another cluster, I automatically have 4 nodes now for 2 clusters. So just thinking about those types of things. The other piece too is licensing. So thinking about how you're going to address licensing. You can bring your own, like Microsoft licenses and such. So kind of think through those. We do support, now I know the mileage is kind of varied, at least with my customers with this, but we do support removing physical CPU cores. So when you create a cluster, you can say, hey, go ahead and use all cores inside every host, or I can limit the amount of cores that I actually physically turn on in each of the bare metal instance. So we do support that. The cost doesn't change on our side, but hopefully your licensing contracts.
That's a concern I have, because we've talked to Microsoft and they've said, okay, as long as you use dedicated hosts, right, you're pretty good on your license. But host is different than instance, right? And so obviously a dedicated, so.
Yeah,
But that's where the VMC comes in as handy, because then you know, okay, I've got this cluster of hosts, and I know what hardware is on that, and I can run my virtual machines in that cluster. I'm compliant with my licensing with Microsoft.
Exactly. Any other questions?
If not,
Okay. You take a look at our virtual machine. Yep, there it is. So yeah, we moved it from Virginia to Ohio.
those follow up on that. At what level do we dedicate the region we are working on, the SDDC level or the VPC level?
Yes, so yes, okay, so the VPC you create per region, right? And then you have the CIDR that you define in the VPC, and then within the CIDR you have multiple subnets. The subnets you tie to an availability zone, right? The SDDC that you decide to, or that subnet that you decide to attach the VPC to when you create it, that's the region the SDDC is going to be deployed into. Or that's the availability zone that the SDDC is going to be deployed into. So it's going to be tied to that availability zone within that region. So I mean, good question in thinking, okay, if I'm looking at straight backups, right? And I want to back up and have my EC2 instances in that same availability zone, maybe for speed, or maybe an RDS instance, right? I might want to pay attention to where I'm placing those. Typically availability zones are within 60 miles of each other, so they're close, but still you might have maybe a millisecond of latency, between those, for example, versus being in, one availability zone. Latency is going to be a little bit less.
Okay.
Anything else?
That was good.
Anything else? We can definitely deep dive in another meeting, or typically next steps. We'll talk more, or we can give it an actual immersion days, so we can you can get into this environment, and play with it, use it, migrate VMs, go through some labs that we have. And then typically from there, some customers will even jump right to a pilot. So initiate a pilot,